Okay, number 4 from 1-7 is a two-parter. They give us three vectors, v1, v2, v3, for what value of h is v3 in the span of v1 and v2. All right, so remember the span of v1 and v2 looks like this. It's the set of all vectors of that form, so that has to be equal to v3 in order for v3 to be in the span of v1 and v2. Okay? But that's essentially a system of equations, and the augmented matrix for that system looks like this. So let's do what we normally do, which is put this thing in reduced echelon form. Three times the first one plus the second one. 9 plus 5 is 14. I can almost stop right there, can't I? Because notice I multiplied the first row by 3 and I added it to the second row. That made that a 0. But 3 times negative 3 is negative 9. That makes that another 0. And 3 times 3 is 9 plus 5 is 14. You almost don't have to do anything else because it looks like there's never a solution to this system. So there is no value for h. Okay, part 2. For what values of h is this collection of vectors linearly dependent? Okay, so that means we have a non-trivial solution of that homogeneous system. So once again, need to set up our augmented matrix. But what does it look like in this case? Well, let's see. I know the right-hand sides of the equations are all 0. And the first column should be v1. Second column is v2. Third column is v3. And that last column is just the 0 vector. So we want to force this thing to be linearly dependent for choices of h. All right. Now, this is a homogeneous system, so it's only going to be linearly dependent if we have infinitely many solutions. We already know that the trivial solution is a solution. So we want to force this thing to have at least one free variable. So keep that in mind. So I'm going to multiply the first row by 3, add it to the second. And I'll multiply the first one by negative 4 and add it to the third. All right. All right, now we want to put this thing in echelon form. And I suppose we could even put it in reduced echelon form if we wanted to. But it looks like I probably want to divide the second row by 14. Next, we'll put it in reduced echelon form. And, well, that means this has to be a 0, and so does that. All right. So I suppose I could make this a 0 by multiplying the second row by negative 3 and adding it to the first row. But that won't change the other entries in the first row. And, well, if I want to make this 0, I suppose I could multiply the first or the second row by 12 minus h and add it to the third row. Okay. So, notice I didn't put any restriction on h here at all. I didn't assume anything about h. and I was able to kind of get rid of it anyway. So let's count the number of basic variables. It looks like this is a pivot column. This is also a pivot column. So my basic variables are x1 and x3. All right. And remember, you don't count the very last column ever as a pivot column. So it looks like the x2 has got to be the free variable. So we do have a free variable in this case. All right. And remember, we were solving a homogeneous system. And a homogeneous system always has one solution or infinitely many solutions. In this case, it has to have infinitely many because we have at least one free variable. And that means that that this system has infinitely many values for x1, x2, and x3 that will make it true. So it looks like the three vectors v1, v2, and v3 are linearly dependent for any h because we didn't have to put any restriction on the h at all. So these things are linearly dependent for any h, and that's the answer. Any value for h.